Hey guys, so this is our lesson on trig proofs. Okay, so I know when you think of the word proof, you're like, oh no, geometry proofs like side, angle, side, angle, side, angle, side, side, side. Actually, angle, side, angle is not one. It's side, angle, side, sorry. All those proofs. Anyway, the geometric ones, those ones you didn't like. And to be honest, I don't like teaching them either. But they're a necessary, not really evil, but they're necessary, even though they're kind of a drag, just because it helps us understand the geometry behind some of those things. But the good news is that these proofs are not like geometry proofs. They are very different. They're trig proofs. Now, trig does have some geometry in there because we're dealing with circles and right triangles and all that jazz, but we're basically using what we know to help solve these, and it's not going to be like those proofs in geometry. Okay. All right. So what we do need is we need to know our identities. So at the top, I'm going to go ahead and write our identities. I'm going to start with the big kahuna. The sine squared plus cosine squared equals 1. So sine squared x plus cosine squared x equals 1. So if you were coming up with a little cheat sheet kind of for when we get ready to test on this, this would definitely be one I would write down. That's the big kahuna. And then we also know that when we divide everything by sine squared theta, sine over sine is 1. Cosine, excuse me, got the hiccups. Cosine squared over sine squared is cotangent squared because they're squared. And 1 over sine squared is cosecant squared. Okay. And then, Lucas, can you let the dog in? And then when we divide the big kahuna, everything by cosine squared, sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine squared is secant squared. Okay. So those are the main identities. Really the only one you have to remember if you're trying to remember it is the first one, because you can easily derive the other two. And just remember, we can rearrange these however we want. Say I just want sine squared to be by itself on one side of the equal sign. Then I could have 1 minus cosine squared on the other side, and so on and so forth. Okay, we saw that in the other lesson. Okay, so these are important. We are going to be using those a lot. And the big idea with doing a trig proof is we need to pick a side. Pick a side and show work until it is the same as the other side. Okay, so again, these are going to be problems where there might be more than one way to approach it, might be more than one way to do it, especially if you're picking a certain side and someone else is picking a different side. Now, for number one, we could pick the side with the 1, but then we're working backwards big time, and that is going to be hard. So it's going to be easier to focus on the left side of that equal sign. So what I'm going to do is I'm going to draw a dashed line through the equal sign to kind of show the left side from the right side. Okay, and I'm going to focus on the left side because I know that I can replace tangent and cosecant with something else. So for instance, tangent, I can write as sine of theta over cosine theta. Do I need to zoom in? Okay. All right. They're next to each other, so that means times. I like writing it in there because that's just me. Or use parentheses. Cosecant is the same as 1 over sine. And then cosine, I'm going to keep it as cosine, but I'm going to put it over 1. Okay, so looking at everything I have going on here, I see that the sines cancel. And also the cosines cancel. So everything canceled, turned into a 1, and we get it to match the right-hand side of that equal sign. So this is basically the proof, getting one side to match the other. Okay, how easy was that? These are not bad proofs. They're not like the proofs that you guys have grown up with in Math 1 and Math 2, although Math 2, we haven't really been doing proofs. It's mostly Math 1, okay? All right, so number 2 says prove the secant of theta plus 1 times the secant of theta minus 1 equals tangent squared theta. Well, I'm going to focus on the side that has more stuff because it's going to be easier to work that out. So I'm going to focus on the left again. And I noticed something. Whenever you see conjugates like this, secant theta plus 1, secant theta minus 1, conjugates have the same stuff, but one has a plus in the middle, one has a minus in the middle. Remember, when we FOIL this out, when we multiply it out, the middle term is going to cancel. So we're going to get something really nice. So I'm going to go ahead and multiply this out. Secant theta times secant theta is secant squared theta. Secant theta times negative 1 is negative secant theta. Then 1 times secant theta is a positive secant theta. And 1 times negative 1 is negative 1. So notice, like I said, the middle term cancels. That always happens when you multiply conjugates. So once you start recognizing that that always happens, anytime you multiply out conjugates, you can just go ahead and write secant squared theta minus 1, because you know the middle term is going to cancel. But you have to know that relationship in order to use that little shortcut. All right, so now this goes down to secant squared theta minus 1. And now I'm like, I need this to look like tangent squared theta. So this kind of reminds me of a identity. And if I look up here, yeah, if I subtract 1 from both sides, I'll have secant squared x minus 1 equals tangent squared x. So I can replace this with an identity. So it replaces to tangent squared theta. And now it matches. Smiley face. So these are cool. I really like these. These ones are like a puzzle. They're so fun to figure out once you get the hang of things. So you really do need to know these identities and know that you can rearrange them. And sometimes rearranging an equation in order to be able to use it for your benefit gets a little tricky sometimes just because we're not used to having to do that. But in Math 3, we should be getting there. We should be getting used to, whoops, I didn't mean to do that. Oh, I keep doing that. I was trying to zoom out. But anyways. All right, number 3. We're going to prove 1 minus cosine squared y over sine y equals sine y. So I'm going to do my little dash thing through the equal sign. Okay. And again, I'm going to focus on the left. Okay. Because I see something. I see 1 minus cosine squared y. So that looks very familiar, and it should, because I can use the Big Kahuna identity. If I subtract cosine squared x on both sides, I will have sine squared x equals 1 minus cosine squared x. So 1 minus cosine squared y, I can replace with sine squared y. So I'll have sine squared y over sine y. And now I have sine squared in the top, sine to the first in the bottom. I can cancel out the 1 in the bottom with one of them from the top. So all I have left is sine y, and boom shakalaka, we get it to match. I forgot to box this one. Okay. These are fun. I like these. I like them a lot. I hope you guys like them too. I really do. Like that too. Hey, you hush. My son's making fun of me. All right, number 4, we're going to prove sine squared theta equals 1 minus 1 over secant squared theta. Well, this time, the right side of the equation has more to work with, so I'm going to focus on the right this time. And I can replace 1 over secant squared theta with a basic identity. 1 over secant squared is the same as cosine squared. So I can replace that and make this 1 minus cosine squared theta. Hey, we're back to this guy. We did that in the last problem. So we can replace 1 minus cosine squared with sine squared. So this will become, so I'm going to circle that again because that's an identity. So this becomes sine squared theta, and oh hey, look at that, we're done. Because now it matches. Woohoo! Smiley face. I expect to see smiley faces when you guys are doing your proofs. No, I'm just kidding, you don't have to do that. But I mean, obviously we're happy when we get to the end and we're like, oh, we proved it. Yay, happy, smiley face. You know you like it.
You know you like it.
All right, so number 5, we're gonna prove that secant theta over 1 plus cosine theta equals cosecant squared theta times secant theta minus 1. Now this one is gonna be your challenging example. So we'll put stars next to it. And let's go ahead and dash through our equal sign. I'm actually gonna focus on the left, so I need to get this to look like this, okay? So basically what I'm gonna be doing here is I am going to be showing you a trick of trig. Trick of trig. Okay, what is that trick of trig? Well, the right side of the equal sign doesn't have a fraction, but the left does. So how am I going to get rid of that? Well, we do know that when we multiply an expression by its conjugate, we eliminate some things. So that's what we want. We want it to get smaller so that we can eliminate that denominator. So what's the conjugate of 1 plus cosine theta? That would be 1 minus cosine theta. Writing it really small, so hopefully you guys can see that. It looks clear on my screen, so hopefully it's clear for you guys. Okay, so we're going to distribute secant theta times 1 minus cosine theta, but for now I'm going to rewrite it just to make sure that we can see everything. 1 minus cosine theta times secant theta is in the numerator. And let's go ahead and FOIL out the denominator. So 1 times 1 is 1. 1 times cosine theta is just a cosine theta. Negative cosine theta times 1 is a negative cosine theta. Negative cosine theta times positive cosine theta is negative cosine squared theta. Okay. And of course, the middle terms canceled. Remember, we multiply conjugates. Their middle terms are going to cancel. That does happen. Okay. In the numerator, let's go ahead and distribute the secant theta to the 1 minus cosine theta. So secant theta times 1 is secant theta. Secant theta times negative cosine theta is negative, let's just put cosine theta next to secant theta for right now. Yes, we can change out the secant theta, but I'm gonna do it step by step. Okay, in the denominator, I'm going to have 1 minus cosine squared theta, because remember those middle terms canceled. And hey, we're back up to that 1 minus cosine squared. So remember, we replaced that with sine squared. So I'm gonna go ahead and circle that, because we get to replace it. And I'm also going to circle the secant theta because I'm going to replace that with something as well. So I'm going to have secant theta minus cosine theta times 1 over cosine theta is what we're replacing the secant theta with. Over, we know 1 minus cosine squared converts to a sine squared theta. Okay, and what gets to happen here? Well, we have cosine theta times 1 over cosine theta. These cancel. Oh, so that turns into a 1. So I'm going to have secant theta minus 1, okay, all over sine squared theta. All right, let's look at the right side of the equation. So I'm going to zoom out. Well, I've got the secant theta minus 1. Now I need cosecant squared theta. Cosecant is related to sine. They're reciprocals of each other. So let's see. if I were to separate the sign, like having 1 over sine squared out front, yeah, that would be cosecant squared. So 1 over sine squared turns into cosecant squared theta, so that's true, and then times secant theta minus 1. So, boom shakalaka, there we go. It works. So yeah, this one was a challenging one, and sometimes you will have to multiply by a conjugate in order to make it bigger, to make it smaller, you know. And to do what?
A black flip.
A backflip? He said a black flip?
A back flip. I can't even do a back flip.
Dude, I can't even do a backflip, so it's
I
okay.
can do a front flip.
On a trampoline.
Yep.
All right, number 6. Do. Okay, so for number 6, let's see. We have more to work with on the right, so I'm going to look at the right side of the equal sign. So I'm going to need to make this a fraction somehow. Well, I can replace secant theta with something. It's a basic identity. Secant theta is the same as 1 over cosine theta. And hey, now I've got only cosine in that expression. Well, let's put the cosine theta over 1, and when we have fractions that we need to subtract, we need to get a common denominator. So we're going to need to multiply top and bottom by cosine theta. Okay, and so we will get a common denominator of cosine theta, and we'll have 1 minus cosine theta times cosine theta is cosine squared theta. Okay, and now that 1 minus cosine squared theta, that should look familiar. This is what, the 4th time we get to use this now? 1 minus cosine squared can be replaced with sine squared. So we're gonna have sine squared theta over cosine theta. And so we have a fraction. I need it to look like tangent over cosecant. So, how can I get a tangent? Well, I know tangent is sine over cosine, and I have sine squared over a cosine. So let's separate this. Let's write this as a sine theta times sine theta over cosine theta. Because now I still have sine times sine is sine squared, and I have cosine theta in the denominator, but now I have it separated so that I can replace sine theta over cosine theta with tangent. And since I need cosecant in the denominator, I can replace sine with 1 over cosecant. So I'd have 1 over cosecant theta times tangent theta. And then multiply across, I would get tangent theta over
Smells like poop.
cosecant theta. It better not.
Smells like poop in here.
Well, take a look and see if you can find it. They better not have gone in here. And I'm recording, so you just told all my students that it smells like poop in here. Embarrassing. Okay, anyways, and that's the last one. All right, so on the back, we're on your second page, is the homework. So you're proving each of the following, so it's just 7 problems. Like I said, draw your little dash mark through the equal sign and pick a side to work with. If you look at number 2, this was crossed out and Miss Ardita put typo because it was an accident, but she didn't want to have to rewrite the whole thing. So yeah, so that's just an equals 1. So ignore that part. Otherwise, that's your assignment. Make sure that you show your work, please. Obviously, because the work or the answer is a proof, so they all should look like this. None of these are just a single answer. And yep, that's it. Have a good one, you guys, and I'll see you in my next video.